Good day to you all. Welcome to the 12th lecture of Magnetic Compass online lecture series. Today we'll discuss about correcting the coefficient. We'll see how the coefficients are being corrected by the compass adjuster. Let's begin. Before starting the correction, let's do some small recap. Let's see what is coefficient. If all the magnetic forces which cause the deviation to change in the same manner are grouped together, then the resulting maximum deviation caused by those forces is called a coefficient. The coefficients are the mathematical representation of the deviation caused in the compass due to permanent and induced magnetism. We already know that when the vessel is upright, there are basically 5 types of coefficients on the ship's compass. However, in the most ships, we have got only 3 coefficients: B, C, and D. Coefficient E and A will not be present in the normal ships. If it is a exceptional ship like aircraft carrier or a heavy lift vessel, those vessels may have coefficient A and E. And we have already seen this table, and we know that coefficient A is due to unsymmetrical HSI near the compass position, and for coefficient B, the reason is vessel's P force and VSI forward and abaft the compass induced by jet. The coefficient C is due to Q force and athwart shape VSI induced by jet. Coefficient D is due to fore and aft HSI and athwart shape HSI. And coefficient E is due to unsymmetrical HSI near the compass position. However, it is not normal for a ship to have coefficient A or E, right? I want you to draw this table, because in this table we have got the characters as well. For coefficient A, we don't use any character, right? And coefficient B, coefficient B is due to ship's permanent magnetism and induced magnetism. To correct coefficient B, we use both permanent magnets and induced magnets. These induced magnets, which is used to correct VSI forward or above the compass position induced by jet, are called Flinders bars. What is that one? I'll discuss that one later on in the following slides. Coefficient C is been corrected by athwart shape permanent magnets and Flinders bars, and coefficient D is corrected by Kelvin's ball. And if the vessel has got a coefficient E, that one will also be corrected by Kelvin's ball, right? What are the Flinders bar, athwart shape permanent magnet, or fore and aft permanent magnet, or Kelvin's ball? We'll see later on, don't worry. So how the compass corrector correct the coefficients? I want you to take this note. If the value of the coefficients are known, characters can be used that will cause an equal opposite deviation to that of each coefficient, leaving the compass free of deviation on any heading, right? So to correct the compass, we need to know the value of the coefficient, and we have seen how to get the value of the coefficient, right? So and we also know that the coefficient B is the maximum semicircular deviation caused by ship's P force and VSI induced by jet. And coefficient B can be two type. It can be plus B or minus B, and both B permanent can be plus B or minus B. Again, B induced can be plus B or minus B, right? Now let's see how to correct B permanent. As B permanent coefficient is the maximum deviation caused by ship's fore and aft magnetism, that is P force. It is corrected by placing sufficient forward and aft permanent magnets in the binnacle to cause an equal and opposite deviation, right? So if we have got a BP which is positive, that means we have got blue pole at the forward, then we'll put the red end of the permanent magnet in the forward, right? And we have, if our BP is negative, that means we have got a red pole in the forward, then we'll put blue end of the permanent magnet forward, right? These permanent magnets are placed on the compass binnacle at the which is situated on the Mancala end. So these are the permanent magnets, right? So and we'll the compass character, according to their value of the coefficient, they place those permanent magnets on the compass binnacle, right? Once these slides are finished, I'll try to make a video where I'll take the video of compass binnacle and I'll show you how these permanent magnets are being placed, right? The correcting of the coefficient B, and which is due to induced magnetism, right? So as B induced is the maximum deviation caused by the ship's VSI induced by jet, it is corrected by placing sufficient soft iron bar, which we call Flinders bar, on the forward or above side of the binnacle to cause an equal and opposite deviation, right? So if you see the compass binnacle, you'll see that you will get this type of one Flinders bar, right? And where actually we put Flinders bars, right, as per the B induced magnetism value, right? So on most ships, VSI is considered to act above or with the level of the compass, right? So therefore the Flinders bars are always placed on the forward, right, and the forward part of the binnacle, right? So you see, if the vessel on the northern hemisphere will get blue pole at the top, so that's why what we do, we'll put a Flinders bar at the forward, and the blue pole of the Flinders bar will be at the forward, right? So this Flinders bar will create an equal and opposite deviation uh, caused by the um, VSI induced by jet, right? Again, if the vessel is in the southern magnetic hemisphere, that time we will have a red pole at the top, so we'll keep Flinders bar at the forward, but the red pole of the Flinders bar will be at the top, right, which will cause an equal opposite deviation, right? This coefficient C. Coefficient C is the maximum semicircular deviation caused by ship's Q force and VSI induced by Edward Ship VSI induced by jet. However, this Edward Ship VSI induced by jet will not be present in the normal shape, right? So again, the coefficient C can be C plus or C minus, right? So how to correct this coefficient C? So this coefficient C permanent is easily considered to be the maximum deviation caused by the ship's Edward Ship permanent magnetism. So it is corrected by placing sufficient permanent magnetic characters Edward Ship of the binnacle to cause an equal and opposite deviation, right? And we have already known, we know that C induced will not be present in the conventional shape. However, if there is any C induced, that time that C induced can be corrected by swinging the Flinders bar away from the fore and aft line, right? Now, how to place those permanent magnets in the binnacle? If we have CP plus, that means if it is a C plus shape, that time we'll place red end of the permanent magnet on the starboard side. Why? Because for C plus shape we'll have blue pole on the starboard side, so that's why we'll put red end of the permanent magnet on the starboard side, right? So in that way, we just place the permanent magnet in the Edward Ship direction, right? If it is on the 409 direction for B, that pattern magnet will be on the adverse ship direction, which will cause an equal and opposite deviation caused by the Q force, right? And if our CP is negative, that time we'll place the radian of the paramagnet to the port side. In that way, actually, we'll correct the CP, right? Coefficient D. Coefficient D is the maximum quadrantal deviation caused by the ship's fore and aft HSI and other ship HSI induced by H, right? So that's why we will not use any kind of permanent magnet to correct the coefficient D. We'll use only induced magnetism to correct the coefficient D, right? We already know that coefficient D can be two type, plus D or minus D, right? So this coefficient D can be corrected by these balls, right? These balls are called Kelvin's ball, and we place those balls either on the port and starboard side or forward and aft side of the compass binnacle. But in the conventional ship, you'll see that these Kelvin balls will be always on the port and starboard side. Why? Because this Kelvin's ball we place on the forward and aft port and starboard side to correct the D plus shape, right? And 99% of the ships on the modern world has D plus, right? Let's see how it is corrected. As coefficient D is the maximum deviation caused by the ship's HSI induced by H, it is corrected by soft iron spheres at the ship or fore and aft of the binnacle to cause an equal and opposite deviation, right? To correct D plus, the spheres are placed on the adverse ship direction, and to correct D minus, we will place the spheres on the fore and aft direction, right? But it is not normal to have coefficient D minus for a merchant vessel, right? Why it is not normal for a ship to have D plus? To have D minus, it is not D plus, D minus, right? So here we have got a ship, right? So here this line we represents the fore and aft HSI, and that line represent other ship HSI, right? As the lines of force are entering on that side. So that is a partially induced ship, and we'll have blue pole at the starboard and at the stern, right? So what happens here, as the poles of the other ship HSI are closer, so if it is the compass needle, so it is closer to the compass, they have greater effect, and the resultant deviation on the northeasterly heading, right? That means on the quarterly heading will be on the easterly, which is by convention D plus, right? So therefore it is very normal for a vessel to have D plus, right? So like if you have got a ship which has got huge breadth, right, and small length, like I can give you a example of ship like if it is a aircraft carrier, that time it may have this huge breadth and a small length, so that time you may have that D minus, but 99.99% time you'll see that the ships are having D plus. Correcting the coefficient A. As coefficient A is the maximum deviation caused by the ship's unsymmetrical HSI induced by H, there is no provision to correct this coefficient. Therefore, it is present. If this coefficient A is present on the ship, it must be allowed for, right? And coefficient E, as coefficient E is the maximum deviation caused by the ship's unsymmetrical HSI induced by H, it is corrected along with coefficient D, and we'll correct it by slewing the spheres out of the adverse ship position towards fore and aft line of the vessel. However, we will not find the coefficient E on the normal merchant ship, right? With that, we'll finish our the first phase of our magnetic compass online lecture series, and I think this 12 lecture will help you to understand the compass better and will help you to answer all the question which has been asked in the class 2 level or class 1 level, in both in the written sessions and oral sessions. Thank you very much, and if you have got any other query, please comment in the video, so that we can I can improve later on. Thank you very much. See you on other class. Thank you.